Thanks everybody for coming along today. We're going to be talking about edge computing and particularly looking at its implications on data AI and really just thinking about where this kind of functionality or capability could go. Pretty simple agenda. I'm really aiming to share a little bit about edge computing, kind of understanding of it, where we're starting to see some sorts of implementations with customers or at least talking about it, and gives kind of some exposition as to how we think it could and probably will impact the data and AI landscape. Just quickly to introduce myself and then Thorogood. So my name is Ben Dunmeyer. I'm a data analytics consultant. I'm based in the US. So for those of you that don't know Thorogood, we're an independent global professional services firm specializing in business intelligence and analytics strategies, solutions, and services. We're a global company with offices in Asia, Europe, and the Americas. As I mentioned, I'm in Philadelphia. All our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding in the form of industry and functional experience, with a strong technical aptitude and deep understanding of analytical tools and techniques. And we do offer a full range of data analytics services. You can see some of those on screen. In terms of the technologies we work with, we are an independent consulting firm, meaning we don't work with one specific technology, but really work across the best-in-breed tools and platforms across the industry. So that's big players as well as niche providers. And really what we want to do is partner with these key players in the market to provide our clients with a solution that best suits their needs. And as we talk about edge computing, there's probably technologies and vendors that aren't on this screen, but will evolve into the future, but we'll keep it in context. So starting out, just giving an idea and maybe a little bit of a definition of edge computing and where we see the intersection with particularly data and AI applications. Won't really get into things like hardware or that's configurations. So again, starting simply, grabbed a few things from the public domain to kind of present the topic. And I guess the concept of edge computing is relatively simple, but just like anything that it's kind of more than meets the eye a lot to actually implement it. But the fundamental idea is that within devices and as technology advances, we have the ability to have both compute and storage within devices or where data is being produced or generated, as opposed to just in some sort of central data hub or central kind of firewalled infrastructure. So the idea of a sensor in an office that is gauging temperature, number of people in a room, or an autonomous vehicle or pieces of equipment in a factory, they're all kind of mechanisms or machinery or devices that can generate data. So that idea of edge computing is bringing the ability to have some level of computation, some level of storage kind of on or right next to that device. The big idea is being able to achieve low latency or really no latency capabilities with data processing, data analysis, and potentially AI applications. So you see maybe the diagram on the right kind of draws out a number of different topics, some examples of these sorts of devices. And it's really thinking about what do I want to accomplish and what are the latency requirements for it. And thinking about the kind of business implication of it, is there an opportunity or a need for real-time, near real-time, or actual real-time analytics? Or is it that and also some needs for kind of traditional business intelligence reporting or operational reporting? So kind of in principle, it's introducing this concept, and again, it's been around for a number of years, and I think getting more and more popular and practical. It's putting the technology and capabilities in place where data is being produced, so we can do potentially some of the same sorts of operations or analyses that we do now in a centralized data store, centralized data hub that we curate and build. Really, I guess I just want to think about how we might apply these sorts of scenarios, what scenarios they might apply for, and what the value add could be. So here I've sort of laid that out. Kind of what is the opportunity, and then how does edge computing sort of fit that bill or allow us to do it? So the first one, I've mentioned this now a couple of times, is real-time or instantaneous decision-making. So really, and again, kind of hits the nail on the head with the ability to have some level of computation and storage on the device or right next to the device, so to speak, that doesn't require movement through networks to some sort of data store and either batch or streaming processing. So effectively allowing us to do low latency or really maybe no latency analysis as the data is being produced. Efficient usage of physical assets. So what I really mean by this, if we, I guess, think about technology, manufacturing sites or smart buildings or kind of any number of other kind of physical things, that kind of hardware, if we use that term pretty loosely, is like going to be idle at times. There's not always going to be someone in a room. A given piece of equipment is not always going to be running. But if it has these capabilities of edge compute within it or as part of its structure or framework, how do you kind of use them to best effect? Like if they're there and they're just sitting idle, we want to be using them, maybe running some analyses or retraining a model or something like that. So it's I guess the opportunity is getting the most out of investments, whether physical investments or data investments, and like thinking about how we can use those investments all the time, and even when they're idle. So something that's, I think, near and dear to us in the data analytics community is the ability to combine new and diverse data sets to get new perspectives or come up with new analyses or uncover insights that have previously we haven't thought about or hadn't been able to prove or disprove. And a similar idea here with edge computing. I would think the angle with edge computing is the kind of nascent or new data sets that can be acquired if able to tap into this capability. And a lot of this is probably technological advances in building these components or equipment that is able to capture information, whether it's like biometrics or information about a vehicle or, again, in a plant, a couple of these common examples I've been using. So, like, with the opportunity to collect new data, what new things can we come up with? Can we improve decision making in any number of areas? And I'll go through some examples later. So, the opportunity to collect new and diverse data that we can use in like lots of different ways. The ability to kind of prioritize or filter information. So we think about any sort of routine. You want to know, should I be doing this? Should this data that I'm collecting from X, Y, or Z, do I need to bring it back into my central hub? Do I need to store it? Do I need to process it? Or should that investment or that time be spent somewhere else? So with the idea of compute, kind of where the data is being collected, we might be able to make decisions to exclude erroneous data or do some like initial evaluation as to what information like has any purpose versus what things we don't store or do store. So I think it gives us a little bit more autonomy and maybe auditability to decide for things like Internet of Things, sensors, what information do we want to bring back into a central data store, because that's going to be an investment. We have to set up those kind of physical connectivity. You have to have the routines that do it. They have to be maintained. So can you filter out unnecessary information, for example? And the last example I have here, kind of thing to call out, is the ability to reduce dependency on any sort of environmental or physical limitations or factors. And again, this one's a little bit severe, probably in some instances. There's probably just a few actual scenarios that come to mind. But if we think about an oil rig or remote locations across the world or somewhere in the ocean like an oil rig, not necessarily have that high-speed network. You might have a high latency network or low bandwidth, very likely. So the average computing giving us some opportunity to do some computation, some data storage, where we don't have the ability to pull all that information or a lot of that information into some sort of central place. And this one's pretty severe. There's probably a few instances of it, but I think it's pretty interesting. So I've alluded to a few, and I think there's some kind of obvious examples of this, and I'd only expect this to grow over time as just like technology advances, hardware advances, and the amount of information we capture just becomes, people have seen studies, exponentially grows. So a few examples here, kind of broken them into some groups, can maybe briefly hit on a few of them or maybe all of them just because they get some interesting examples, and I might be thinking about where it applies to your organization or industry that you play in. So starting from the left, retail is an area where I've done a lot of work and a lot of my expertise is in. So I think of retail both on the front end of the store and in the manufacturing side, which is just to the right. But things like tracking stock. So where are we low on inventory, whether that's in the warehouse or in the actual brick and mortar stores. Potentially the ability to, maybe not in the moment, but pretty quickly get information about promotion effectiveness. So if we run a promotion in a certain display or in a certain aisle, is the foot traffic in that aisle, the days or times when the promotion is active, are they increased, are they decreased, or they stay the same? And like the ability to see that and potentially make almost real-time decisions is pretty wildly interesting. Workplace safety, so you can think about that across various different construction zones and any other, I guess, manufacturing. The top here, I said the example earlier about like an oil rig, but sorts of isolated areas. And again, this is a pretty severe example because there's not that many. But how can these scenarios be better managed, or how can we use data analytics in the scenario where we don't have the ability to pass a high amount of data to a central data store and get it back and make any use out of it. Healthcare, so you might think about patient monitoring, so being able to pick up on the numerous biometric and other signals that you can get from monitoring a patient. Something like room availability in a hospital or in an office. Transportation, so autonomous vehicles, one that is kind of often in the news right now. Traffic management, monitoring emergency vehicle responses or even pathways. So I think transportation's an interesting one that a lot of us experience every day. And a few other words here, I'll probably leave them to read through. But I think a number of interesting use cases to think about. As I said, I think it will only grow as technology advances. As we're able to collect this data from more diverse places, and it's kind of interesting to see where it goes. And ultimately, if the hardware and technology is in place to be able to do it, can we actually take advantage of it? So I'll try to frame us a little bit in how the kind of concepts of edge computing and some of these use cases, which are kind of a little bit ubiquitous or kind of generalized, how might it impact data and AI? And again, not going to jump into any details here of how to do it, but I really wanted to think through what are the components and how might we adopt or use the theories and the practices that we've developed over years and continue to develop in kind of building data architectures, and these use cases which present some physical limitations in the hardware and what we can do, and some kind of practical limitations, I suppose. Give an example, and again, not to any level of detail, but hopefully frames it a little bit and gets us thinking about what we need to make this a reality or potential reality. So I'll use the example of a manufacturing plant. I think it's a pretty kind of on-the-nose example, just given the number of different use cases like monitoring equipment for controlling it, but also for identifying things that have a high probability of failure or faults given the amount of time or usage, are pretty common use cases. Other things being like climate control or building control, which is just not necessarily manufacturing. Identifying quality issues, so if you can spot problems with goods ahead of time using some sort of video surveillance or even information coming from the machinery that is producing the products, we can get ahead of quality issues. And I'm sure an endless list of theories and ideas. But maybe let's, for the example, think of a classification or probability model that we've developed and want to apply in order to identify faults or failures or the likelihood of them on either subset equipment or certain part of the process, whatever it might be. So we have that, and we have our edge devices across this manufacturing plant. And we, of course, have our enterprise data and AI architecture. Doesn't really matter the technology stack, likely multi-cloud, multifaceted first step, but likely we are bringing this data into our data platform, so I've assumed some sort of data lake here. And again, this I'll get to the actual edge part of it, but with the edge device or the Internet of Things device, we're able to pass through telemetry and other information in some sort of structured way, and we land that data. So whether it's files or presumably in files, we land it somewhere in a data lake, and then we have a pretty kind of natural way or learned way of curating that data, whether it's streamed or batch. So we might organize the data, apply restatements, do some data cleaning, whatever else it might be that makes data either more presentable or easier to interpret or whatever it might be. Often kind of interpreting logs is something that we run into. We know how to do that. We do that all the time. That's the bread and butter of a data and AI architecture, collecting data, transforming it, and then using it for various different things. So it's the same, more or less. Here, we're not thinking about a high velocity of data, and I'll kind of formulate the picture and come back to it. So with that curated data, we can do some data analysis, we do a reporting, we do analytics on it, whatever else. So we've kind of built something that we're pretty familiar with, and we'll assume that we're not necessarily feeding a stream of data, and we don't need to do that in this case. I think this could be a batch, or it could be every so often collected from the edge devices. Where we have the facility, so the kind of the scalability and elasticity of cloud and the kind of software to do so, we'll build and train a model. So again, we have history data, we have hours and hours or months and months of telemetry data from these edge devices, and we're able to develop a model that is helping us to predict either the probability or the likelihood of a fault or failure for a piece of given equipment. So again, I wouldn't expect us to be building or training this model. I guess you could train it on the edge device, but you're first using that device to collect information, maybe to do some potential structuring of it, but then developing a model and then deploying that model. So having some mechanism to physically push that model into or onto the edge device, kind of completing the feedback loop, so to speak. And the idea here really is we're taking advantage of our known cloud and data architecture where we can build these sorts of solutions and able to then kind of move some of the compute or storage requirements onto the edge device. So we don't need this data to come in at a super high velocity all the time into our kind of main platform. We're able to have a model on the device that interprets this data and whatever spits out a result on a gauge or use our imagination exactly how it transmits this information. And then the whole idea of kind of retraining. So we're at whatever interval sending new telemetry data back into this platform, or maybe we have some ability, given the compute possibilities on the edge device, to do some kind of example retraining or to do some monitoring and logging and detection of any skew or detection of any drift of the model, for example, on the edge device. And then we take that information along with new data, send it back through our kind of loop, retrain a model or whatever it is, and then redeploy it. Practically, we're not going to do everything on an edge device, but we're taking advantage of a number of different facets of doing a bit more on that device and integrating it with our kind of tried and true platform. The other things that really stick out to me are some of our core capabilities for operating and running systems, data systems. And if we think about doing something like this, if we're relying on edge devices to run a manufacturing plant, you've got safety to consider. The livelihood of the business is predicated on this. You want to have some reliable, consistent routines that allow you to manage this. So introduce the ops. You could put different acronyms in front of it, but DevOps and MLOps, particularly in these instances. So do you have the right DevOps setup to be able to manage the data engineering and data collection routines, the MLOps configuration to be able to manage the model, to be able to interpret information coming from the edge device, to understand drift, understand logging information, collect new data and retrain the model or just rescore the model. And then what does it actually look like on the edge device? How are we deploying code more or less to that edge device? I'm showing practical ways to do that. But what does it look like there? How are we introducing some basic routines to either clean data or produce an analysis or even produce an output that then gets visualized in some sort of screen at the manufacturing plant or on the device or whatever it might be. So I'm starting to think about not just like the data manipulation, the data transformations, the routines, but how do we actually can manage it? And again, won't try to answer it here. Won't get into any details, but kind of where my head goes. Looking at the tool sets now, and I think this is an area where we're going to see the most development, the most growth, really. Not always start, but naturally start with the big cloud vendors and usually the leaders in this space, particularly for data and AI. So Azure, AWS, and GCP. There's a few other players out there as well, but the big players. I've just listed out here the technology stacks, if that's the right word. That it seems that's how the software vendors are positioning them as kind of stacks of edge or stacks of IoT capabilities. And again, just listed the names here for awareness. Really what it looks like the cloud players are doing is they're figuring out the infrastructure side of things. And that'll be an interesting play. Does Microsoft produce devices for these different use cases? Does AWS, does GCP do the same sort of thing? Or are they going to create the software that can get installed on edge devices which are created by traditional manufacturers? So it'll be really interesting to see, certainly across each of these platforms, and the build out of the technology stack. And really it's an infrastructure capabilities, and then leaning into the data analysis, machine learning, data collection, monitoring capabilities that will be needed to ultimately kind of see a edge computing vision come to life. Some of the kind of questions that come to my mind, things I was asking myself, kind of list them out here. Do we see the big hardware producers, Dell, IBM, others playing in this place? Are they, their expertise in hardware, are they going to develop the hardware, the actual edge devices, partner with the cloud vendor, or try to do it themselves? Do we see digital native companies just innately able to do this? And in that case, we may not be thinking physically as much, but are they able to either produce products that we're adopting and using these scenarios fully? Is it kind of fully packaged together? If we think about those that are actually manufacturing this equipment, so building sensors or building the edge devices that go and sit on machinery or a turbine or whatever it is, Are they partnering with one of the cloud vendors? Are they doing it themselves? So I think it's interesting to see. I don't think we quite know. A lot will probably depend on how lucrative this space is, who jumps into it, who's able to make it a practicality. And I think the world we live in right now with microchip and like precious metal challenges in supply chain, does that slow this down, or does that constrict the players that could potentially compete here? So this is, I think, an area we have to monitor. We have to see what the kind of cloud software data vendors are doing and see who else either enters the space. The other takeaway I have is that it's not so different, but it's not so different than what we've always had to do. It's just happening in a different place, and I suppose introducing some physical practicalities and the need to be responsible in the usage of the limited compute or limited storage that we have. But really, it's that intersection of data engineering, data science, visualization, DevOps, MLOps, and probably other bubbles you could put on here. But it's getting all of these right into a single solution to make it a practicality. If we have inefficient routines that collect data and transform it, we're not going to actually take advantage of that low latency or no latency connection if we have routines that take forever to run. If we don't have the appropriate ML or DevOps capabilities to kind of make changes in real time or collect enough information to adjust infrastructure configurations or whatever it might be, it's not actually going to work. So we've got the same foundations of data and AI existing here, but it's obviously learning about the nuances or the keys to make something like an edge computing use case or edge computing implementation successful. And also layered in is what are my business objectives? What's my strategy, my technical strategy, my business industry strategy, and what's someone's physical footprint? There's a obvious capital expenditure here. Do you retrofit existing facilities or equipment with these devices? Is it only net new, smart buildings or smart grids or new vehicles that you apply these sensors to? So there's questions there as to like, what's the investment? Where does this apply? And how do you, just like we always are thinking about the merging of legacy systems with new systems, which just is a continuous cycle. How does it work here when pretty diverse, kind of diverse new application? So I'll close out here just about out of time and just leave a few thoughts here. I didn't really talk about the challenges. I guess some of them are obvious, but like, how do you come up with some approaches that do combat the kind of known challenges of edge computing and the ones that we kind of expect to see as it actually becomes a reality? So there's the physical practicalities, like I mentioned, of actually procuring the equipment, installing it, maintaining it over time. You do have to have some level of connectivity. What about security? So if you just kind of have data and potentially some intellectual property stored on these devices, do you need to secure those devices? I don't know, we have to think about data sovereignty at all, but probably. What's the fit with your existing data and AI strategy? I mentioned this on the previous slide or two, is like, where does your business want to go? Where are you going with your technology strategy? And how do they work together? Again, I think edge computing is a facet of one's overall data and AI strategy. It could be opportunistic of use cases. It could be a kind of wide rollout and a big bet that someone makes. But I think if you can get that right, if you can figure out the scalability of kind of a base cloud architecture that I guess cloud does enable us to do, if you can get that right with edge computing, with these other new and interesting capabilities, which will, next year it'll be something different. Like, if you're able to scale those together and effectively and with minimal rework, I think that's the real differentiator. I mentioned a little bit, what's the landscape in terms of providers look like? Are we going to see the mainstays in the kind of data and AI space like lead here? Will it be new players? Will it be kind of conglomerates or partnerships? It'll be interesting to see, given the uniqueness potentially of the hardware that's needed. And then really, how would you get started? Or I'm sure in certain industries it lends itself naturally to that are already doing this. How do you accelerate? How do you make better use of the investment? How do you kind of make use of idle time? All those sorts of things. And again, maybe impossible question to answer, but an area to start thinking about either use cases you have or opportunities that you see to implement this, or an assessment of what your 10, 15, 20-year data strategy might look like. So I'll close out here. I've just listed out a few areas that Thorogood can help, and again, and kind of some of the exploration or thinking around edge computing, but a number of other things. And you can see those listed here, kind of a full range of services that we offer. Of course, do get in touch if you want to talk about this topic or any other topics. Always happy to discuss, share perspective on it. Thank you very much for attending. Appreciate your time today, and have a good one. Thank you.